Hello everyone, welcome back to another exciting chemistry video lessons by Adrenaline, the Bazooka Prophet. Now in this particular video, which is a crash courses for students that are preparing for post-UTME in various universities, and especially for those of my friends and brothers who are preparing for post-UTME University of Benin. This is a crash course which we're going to be diving into from the very foundation and from the very beginning. So even as we start these crash courses from the very introductory aspect, talking about the nature of matter and also separation technique. Now you have to sit and relax as we do a quick review on this particular aspect from the very start. Now we start with the intro, matter. Of course, you agree with me that matter is anything that has weight or mass and can occupy what space. Now that will tell you that even though mass and weight are mentioned or are often used interchangeably in chemistry, they are not the same. For example, mass is the quantity of matter a body contains, and that also the mass of an object is the same everywhere, unlike weight that is defined as the gravitational pull of an object towards a center, or the product of mass multiplied by the gravitational acceleration. Of course, the weight is not the same everywhere you go. Now, even as we dive deep into this nature of matter, we should understand that there are basically three physical states of matter, which are the solid, the liquid, and the gas. There is a fourth one, which we call plasma, but it is not often used in this aspect of chemistry, which we are to focus our attention on. Plasma is a state of matter that is found in stars and whatnot and lightning. All these are of part and parcel of plasma. Now we start with the very intro of the solid. Of course, solid have definite shape, definite volume. Examples are, we have ice, we also have wood. We move down to liquid state. In the case of liquid do not have definite shape. They only take the shape of their container, but they have a fixed volume. Of course, what's volume? Volume simply means the space an object occupy. The space an object occupy. I, for one, as Dr. Adrenaline, the Bazooka Prophet, am occupying a space in this earth cross. Even in this my studio I am actually using to make this video for you, so that you should be relaxed and enjoy yourself. Then we move straight away to gaseous state. In the case of gaseous state, they do not have definite volume, they do not have definite shape, right? So you should get those three differences even as we have outlined them out. We leave there, we then talk about properties of matter. We start first of all, what are properties? Properties talks about the identification of matter or the characteristics a matter exhibits. And we have two major properties of matter. We have the physical properties, we have the chemical properties. Now, what are physical properties? A physical properties, they are properties that do not alter. You see this word here? That do not alter the identity of a substance. Right? Now, examples of physical properties. We have the boiling point, the melting point, the density, we have hardness, we have malleability. Malleability means to be malleable. We have crystalline form, and also we have the senses. And the senses can include the odor, right? The color and the taste. All these are all these are what formulate the examples of physical properties of matter. You need to understand all this because in post-UTME, they tend to test you from all these aspects. Now, you should understand that for students preparing for UNIBEN post-UTME, your questions are into two. You have that of the English, you also have that of the general paper. The general paper, for those of you preparing for biological sciences and engineering, for those of you preparing for biological sciences like medicine, nursing, and all that area, they tend to give you biology, physics, chemistry. It is not how much you know a particular question, it's how fast you are and how good your IQ is to process this question and get your answer accurately. Because, for example, UNIBEN post-UTME processes are very easy. Dividing your JAMB score by 8 and your post-UTME score by 2. Add all together is what gives you your aggregate. And take note, any course can be given to you that you have proposed in your mind when you take this your post-UTME very seriously. That is why there will be a series of videos that I will be doing for post-UTME students exclusively. So do well to always subscribe to my YouTube channel to get more updates. And for those of you who want to register in my online classes, live online classes, where we solve so many questions on every topic I am teaching you right now. We solve like 100 questions that are recent. Not only that they are also recent, they have the potency to come out in your post-UTME exam for you to have good scores. And the fee is always very affordable. So you can always send a message to my DM or to my WhatsApp line, even as we continue. Now, we've talked about the physical properties. Right now is the chemical properties. What are chemical properties? They are properties that indeed alter the identity of a substance. Examples of these chemical properties you should want to know are: one, we have what we call flammability. When something is burned, combustion process, when something is burned, there is no way the identity of the substance won't be altered, right? We have talked about that of the flammability. We'll talk about again too the rusting of iron. We have combustibility. We have corrosiveness. Not only that, we also have reactivity with acids and also with water. Again too, there are still some tips I'll be letting you know. For example, in the roasting of iron, two conditions are favorable, or two conditions must be adhered to, or two conditions must be met. What are they? We have water and oxygen. So we combine it to say moist air. So you need to understand the dynamics of how questions are asked in post-UTME and also for students who are going into SS1 or grade 9. You see, chemistry is actually very fun. Very, very fun. Now, we go down to understand that it is physical properties that lead to physical changes, while chemical properties are what lead to chemical changes. Now, what are physical change? What are chemical change? Now, a physical change is a change, right, that is easily reversible, but no new substances are formed. But a chemical change are changes that are not easily reversed, but new substances are formed. Take a deep breath. Take a deep breath. It's fun, right? Now, what are the examples of physical changes? Of course, one, you understand, dissolution. Let me spell for you. Dissolution of common salt in water. The chemical formula for common salt is sodium chloride. Your normal salt you make use of at home. Now, listen, the solution of common salt in water is an example of a physical change. Not only that, we also have other numerous examples. We also have magnetization and demagnetization, meaning magnet. If a sand should be mixed with ions, you can separate that magnetic material from the non-magnetic ones, right? Take note of this particular point. But even in this year WAEC question 2025, a question was asked as part of the questions in the theoretical part. And I can tell you, some students will find it so difficult. That is why we are doing a quick review or a quick revision work on this aspect. First of all, congratulations to students who just wrote this year 2025 WAEC exam. Let's now fall back to base. Now, that's number 2. Number 3 is the changes in the state of matter. Changes in the state of matter. Now, what are some of these changes in the state of matter that are aligning with physical changes? We have liquefaction, we have sublimation, we have melting, we have freezing, right? We have vaporization. All these are examples of changes in the state of matter that falls under physical changes. Be very careful, because a lot of students will be expecting all this in their exam. No, you need to know these changes. They can tell you an ice cream, when it melts, right? What changes is it? Is it physical? Is it chemical? You need to know. You need to understand how questions in A level, in O level are patterned for post-UTME students or UBTH nursing exams. Is that all right? Now, when we go deeper, we've talked about number 3. Number 4 is separation of mixtures. Now, what are the examples of this separation of mixtures? We have, of course, we have what we call filtration. We have sublimation again. We have a fractional distillation. We have crystallization. All these are examples of what methods in which mixtures can be separated, which we will talk about in our next episode. Now, these are all examples of what now? Physical changes. Quickly, we run into chemical what now? Chemical changes. Of course, we have already defined what chemical changes are. Now we talk about the examples of physical changes. Talk about the first one is rusting of iron, burning of paper. When you burn a paper, of course, take note, when a paper is burnt, right, some things should be taken note of. One, you cannot get back that paper, right? And again, new substances are formed at that particular process. Why? The ashes or the ash is now the new substance, right? So that's the first one. The second one is fermentation and decay of substances. When substances ferment or when they decay, it is an example of chemical changes. Of course, changes in electrochemical cells, right? And also addition of quicklime to water. When water is added to quicklime, slaked lime is formed. Quicklime, the chemical formula for quicklime is calcium oxide. Take note for post-UTME students. Calcium oxide is the drying agent for ammonia. Take note. I'm trying to just why the chemical formula for slaked lime is calcium hydroxide. Like from the way the formula goes like this, I'm having quicklime plus water, right? It gives me what now? Calcium hydroxide. This is quicklime. Why this is what now? slate what now? Slate line. I hope you are understanding this bit by bit revision work that we are actually talking about in this aspect. Now we've talked about this aspect, then we then move to, of course, you should understand some of the differences between physical changes and chemical changes. Of course, in physical changes, no new substances are formed, but in chemical, new substances are formed, right? In physical change, it is not easily reversed. In physical change, it is easily reversible, but in chemical change, it is not easily reversed. That is in the case of chemical changes. Of course, in the case of physical changes, there is no change in mass, unlike that of the chemical changes that change in mass do occur, right? Of course, a considerable no considerable heat changes is released except for the latent heat of what now? Latent heat of fusion, right? So all these are, but in the case of chemical changes, there is a considerable heat changes that do occur in chemical what now? Changes. And this is what actually gives us a food for thought. All right. So while we continue in this particular video talking about the chemical changes, we've also spoken about all the examples of chemical changes. Now we need to now go straight down to other areas under the nature of matter and what now? Separation techniques. Now you should understand that basically substances are into two. We have what we call pure substances and impure substances. In some tests, they often refer to impure substances as mixture, meaning they remove the impure substances and they put mixture, meaning pure substance and mixture. Now, you should also understand that examples of a pure substance include elements and what? Compound, right? These two words are all embodiment of the head pure substance. Now, when you say a substance is pure, what are we saying? Now, a pure substances are substances that has a fixed volume. They contain one type of atoms throughout, and they tend to leave one spot on a chromatogram paper. That is why they are pure, because they consist of only one type of atom. Unlike that of impure substances, that is the direct opposite of pure substances, meaning that in the case of impure substances or mixture, they consist of different types of atoms, right? And they tend to leave more than one spot on the chromatogram paper. This we tend to know at the end of this video under the criteria for the purity of a substance, which is relevant in all fields. Now we then move to elements as our heading. Elements. Now, what are elements? It is a very simple area. In fact, for you to be a chemist or a science student, even non-science students often know how to define elements because it is an everyday known substance. Your gold, your jewelries, your golds, your silver, your copper, many other stuff that you see around you are all elements. Now, what are elements? Elements are substances which cannot be split or divided into simpler form through any known chemical or physical what now processes or means. Now, elements can be classified into what now? Into three major classes, which are melters, non-melters, and semi-melters, which is also referred to as metalloids. Right? Now, during the course of this video, we're going to be going deeper into the understanding nature of all this. Now, you should take note that elements that we know today, as of today, there are 118 known elements, starting from hydrogen, which is the first one, to organoxine, which is the second one, which is the last of the elements. You should understand some certain things about elements. And what are they? You should understand that elements, as we know them, right, are represented by symbols, right? And the first letter of an element must be in capital letter, while others that may come after that first letter must be in small letter. That is why a lot of students often confuse this and this. This is a compound, this is an element. This is cobalt element, this is carbon 2 oxide or carbon monoxide, right? Now, there is so much I might not want to say due to time, because we are trying to see how we can revise this aspect, right? But just know that elements are represented by their symbol, and that the first letter of an element must be in capital letter, and every other element that tend to come with it must be in small letter. Now, we've talked about some things about elements. Now, elements are arranged in a table called periodic table, and this is based on the arrangement of these elements according to their atomic number, meaning elements are arranged in the periodic table according to their what now? Atomic number, not mass number. Or you can also say elements are arranged in the periodic table according to their what now? Proton number. Why? Proton number is same as atomic what? Number. Now, elements are grouped, or elements are into groups and periods, right? And we have 18 non-group and 7 period. We talk about melters. Now, we said that we have 3 classes of elements. We have the melter, we have the non-melter, we have the semi-melters, right? Now, let us continue. Now, we should understand what are melters. Melters are elements that what? That when they ionize, they lose electrons, meaning melter loses electrons, and when they lose electrons, they become positively what? Charged. Non-melters, they tend to gain electrons when they ionize. When they gain electrons, they tend to be what now? Negatively what? Charged. Examples of melters, we have calcium, meaning group 1, group 2, and some part of group 3, and transition elements are all melters, right? In that group 1, hydrogen is not a melter. It is just placed under group 1 for convenience sake, not to make the periodic table to be ambiguous, right? So when we continue, examples of non-melters, starting from group 4, not all elements in group 4, but group 5, group 6, group 7, group 8, they are all what now? Non-melters, right? Because when they ionize, they tend to what now? Lose. Sorry, they tend to gain electrons to become what now? Negatively charged. Although group 0 element, which is group 18 element, they are stable. They are stable. Even in that group 18 element, not all are stable. Some can still react. Example is xenon. The chemistry of xenon is for another day, so let's not go much deeper, right? But in our live Zoom classes, I tend to go deeper for our students. Now, when we go deeper from the word semi-melter, they tend to have the properties of a melter and also a non-melter, right? Examples of semi-melter, we have arsenic, right? We have boron, we have antimony, we have what else, what is it again? They are a couple of elements that are semi-melters or metalloids, right? Which they are mostly used as a semiconductor. Then we talk about lastly the physical properties and the chemical properties that differentiate between melters and non-melters. For example, under the physical properties, metals are sonorous, meaning they produce sound. Metals are sonorous, non-metals are non-sonorous, right? Metals has this lustrous, let me spell for you, lustrous meaning these shiny appearances, but non-melters do not have these lustrous appearances, although excluding carbon, right? So while we talk about metals that are lustrous, we should also understand that non-melters, although carbon, right, is carbon has two allotropes, which are the crystalline and non-crystalline allotropes. But under the crystalline allotrope, we have the graphite and diamond. These are special cases in chemistry. Now, diamond produces these sparkly or lustrous appearances. So, diamond is an exception to that rule. Now, non-melters, right? Non-melters are non-malleable, but metals are what now? Are malleable, right? Now, of course, melters have high tensile strength, but non-melters do not have tensile strength. Again, too, you should understand that melters, right, can conduct electricity. Non-melters cannot conduct electricity, excluding carbon again, which is graphite. Graphite can conduct electricity because it has a free mobile valence electrons that it can use to conduct electricity. Now, of course, lastly, melters, right, have high melting and boiling point. Non-melters do not have high melting and boiling point, excluding carbon again. Examples of that carbon there is diamond. Diamond have high melting and boiling point. Quickly, the chemical properties of melters and non-melters. Take note, melters are good reducing agents. Why? When they ionize, they lose electrons. Non-melters are good oxidative agents. When they ionize, they tend to what now? Gain electrons. Now, number two differences of their chemical properties between a melter and a non-melter is that melters, right, they form basic oxide with oxygen. Non-melters form acidic oxide with oxygen. Number three is that melters tend to form ionic compounds, while non-melters tend to form covalent compounds. Lastly, some melters have the tendency to displace hydrogen, right, from an acid, but non-melters cannot do so. And this marks the end of this particular of this first episode. Now, in our next episode, we'll talk about more. Remember humble self and adrenaline the BAZUKA prophet. Remain blessed. Thank you. And do not forget to share, like, and comment. God bless you.